So first, we're going to hear from Paul Messina, the director of the Exascale Computing Project. And then following Paul, we'll have each of the participating vendors say a few words, and then we'll go into a Q&A session. So with that, let me introduce Paul Messina.
Thank you, Mike. Well, first, thank you all for joining us today. This is quite an important milestone for the Exascale Computing Project and for the nation's exascale imperative overall. Each of you should have received a copy of the news release, so you can see that tomorrow at 2 p.m. Eastern, an announcement will be distributed from Secretary of Energy Rick Perry, announcing that the Exascale Computing Project is making research funding awards to 6 leading U.S. technology companies as part of the ECP Path Forward program. In total, we're making 6 awards totaling $258 million. Now, one important thing to note with this announcement is that the amount is allocated over a 3-year contract period, and the companies receiving the awards will provide additional funding amounting to at least 40% of the total project cost. So that brings the total investment for the Path Forward program to at least $430 million. Now, Path Forward is critical to moving hardware technology forward at an accelerated pace. And by that, I mean accelerated beyond what the vendor or computer manufacturer roadmaps currently have scheduled. An additional way to characterize this aspect of Path Forward is that it bridges the gap between open-ended architecture R&D and advanced product development that's focused on the delivery of first-of-a-kind capable exascale systems. Now, as many of you know, the Exascale Computing Project employs a co-design process that brings together a wide range of sources to address the 4 key challenges of exascale, which are parallelism, the massive parallelism we expect, memory and storage, reliability, and energy consumption. So specifically, the work funded under Path Forward has been strategically aligned to address those key challenges through development of innovative memory architectures, higher speed interconnects, improved reliability of systems, and approaches for increasing computer power, capability, without prohibitive increases in energy demand. And my last point is to emphasize that it is essential that private industry play a role in this work going forward in our co-design process. That is why we're pleased to announce the following U.S. technology companies as the Path Forward Award recipients in alphabetical order: Advanced Micro Devices, Cray Incorporated, Hewlett-Packard Enterprise, International Business Machines, IBM, Intel Corporation, and NVIDIA Corporation. And with that, let me turn it back over to Mike Bernhardt.
Thank you, Paul. So before we go on to having the vendors say a few words, we have a first question that came in from Shaheen Khan. He asked, how does this investment by the U.S. compare to other nations, for example, the European Union?
Okay, would you like me to field that question right now?
Let's take that one right now.
Sure. Well, I don't have detailed information on the investment from other countries or world regions, and in particular, I would underscore that these funding awards are for research and development. They're not for building systems. Whereas it's my understanding in some other countries, the R&D investment and the building of systems is mingled together, and I don't know the separation. I will say, though, that this is R&D, and it's nearly $500 million over 3 years. So what I can say is it's certainly very sizable, but I would be guessing if I were to say that it's more than other countries are doing for this type of work, as opposed to actually building the hardware. But it is very sizable. That's the best I can say for that question.
Okay, let's move on and let's hear from our participating vendors. We'll start off with AMD. Do we have Alan Lee on the line?
Hey, can you guys hear me now?
We can hear you.
Fantastic. So good afternoon, everybody. My name is Alan Lee. I'm AMD's Corporate Vice President for Research and Advanced Development. First, I'd like to say it's a huge honor for AMD, through our Advanced Research subsidiary, to be selected by the U.S. Department of Energy to participate in this Path Forward program, and we're extraordinarily excited to contribute toward the nation's exascale capabilities. Exascale is important to us because it pushes the limits of computation, which of course in turn forces industry to innovate more and faster. While the focus of the Path Forward program is primarily on HPC, the benefits of higher performance, lower power consumption, efficient accelerator architectures, these are all things that are directly applicable across a wide range of computing platforms, from mobile devices to cloud servers, as well as computational domains such as machine learning, data science, enterprise computing, and more. Path Forward provides an outstanding opportunity for AMD to work directly with the DOE on key technologies for exascale computing. This program builds on our previous exascale work with the DOE, continuing and deepening our focus on supporting the DOE's goals. This type of industry/government collaboration provides us with additional insights and perspectives into the country's most pressing computational problems, allowing us to innovate and develop AMD technologies to address those challenges. To this end, AMD continues its long history of innovation and brings many unique technologies and capabilities to enable a path to exascale computing. These capabilities include AMD being the only vendor with both high-performance x86 CPUs and world-class GPU accelerators, our advanced heterogeneous computing architectures, our open-source ROCm software stack for heterogeneous computing, and our leadership extends to advanced packaging technologies such as the in-package high-bandwidth memory we have been shipping in GPUs for over 2 years, as well as sophisticated multi-chip module designs such as those recently announced for EPYC on our server CPUs. Our participation in the Path Forward program starts with these technologies, but then accelerates that research and development to enable these technologies to support the DOE's exascale computing objectives. Our Path Forward R&D activities include streamlining GPUs for HPC and machine learning, taking x86 CPU performance to the next level, providing advanced memory organizations to feed the compute engines, developing node and system architectures that are easier for programmers, supporting open next-generation interconnects for tying together the components of the system, and enabling novel integration technologies to maximize the performance per watt of the final systems. These activities all enable AMD to produce world-class components that our system integrator partners can select and combine in a variety of ways to construct high-performance systems tailored to meet their own and their customers' needs. The Path Forward program is just one indicator of what an exciting time it is for AMD, for HPC, and for computing in general. We are very much looking forward to continued co-design engagements with the DOE to develop optimized solutions for HPC, for machine learning, and data science for exascale computing. Thanks for your time, and we're very happy to be participating in Path Forward.
Thank you very much, Alan. That was really well stated. Let's go on to Steve Scott with Cray.
Thanks. Cray is solely focused on delivering scalable capability compute and analytic systems. And we're committed as a company to developing exascale supercomputing systems on the time frame laid out by the Exascale Computing Project. We believe that HPC, both advancing to exascale systems and beyond, is vital to the country's security, industrial competitiveness, and scientific advancement. The Path Forward project is an important stepping stone on this path to exascale, and we're both honored and quite pleased to participate in the project. Achieving exascale will require long-term investments to advance a number of technologies and capabilities, many of which are not needed by the larger market. And as such, government co-investment is a vital part of achieving exascale, and we're pleased to see programs like Path Forward get implemented. The DOE is also at the forefront of capability use cases. So having an opportunity to work with DOE researchers to co-design systems along with the future applications that they're driving is extremely helpful. Now, when people hear exascale, they often think about the peak floating point performance of a machine, but at Cray, we care very little about peak performance. We're really focused and committed to delivering sustained performance on real workloads that matter to our customers. And of course, as many people have noted, there are multiple challenges to achieving sustained exascale performance. There's the power efficiency of various components, as well as the power and cooling subsystems and overall system power management. There are the architectures of nodes and memories, interconnects, and storage. system manageability and resiliency at scale are particularly challenging as we push the frontiers, including scalability of interconnects and scalability of operating systems, programming environments, compilers, tools, libraries, etc. Our Path Forward project will focus on several of these topics, as well as building systems that are highly flexible and upgradable over time in order to take advantage of various processor network and storage technologies. We very much look forward to working with the DOE on this project and to helping advance the high-performance computing capabilities of the United States. We're quite pleased to participate. Thanks.
Thank you very much, Steve. We'll move on with Mike Vildabil from HPE.
Hello, this is Mike Vildabil. I'm Vice President of HPC Advanced Technologies at Hewlett-Packard Enterprise. On behalf of myself and co-lead Paolo Faraboski of Hewlett-Packard Labs, we're pleased to participate in this program. As a market leader in HPC and a large share, a vendor providing a large share of systems on the top 500 list today, HPC is a natural participant in a high-end R&D development program such as Path Forward. HPE has invested heavily into this market and continues to invest heavily into the high-performance computing market, as evidenced by many of the products we bring to market and the recent acquisition of the Silicon Graphics, or SGI, recently as well. We realize that there are fundamental advancements required to achieve the scalability and the power efficiency and performance needed to realize exascale and to realize the capability exascale systems that are really required by customers and agencies such as the Department of Energy. HPE's Path Forward program leverages several years of R&D investments that we have made into innovative memory-driven computing technologies. You can referring to a project that HPE refers to as the Machine. As one example of heavy investments HPE has made into driving some of the memory-driven architectures that we believe are fundamentally required in order to achieve and realize the power efficiencies that are really demanded as we look out at future exascale systems. So Path Forward will significantly accelerate the pace of our development and will allow us to leverage activities and former investments such as we have in the Machine. And our goal here and our primary target and focus is on enabling these technologies that are crucially important for mission critical HPC applications that we see in the field. So for example, we plan to accelerate, this program will accelerate R&D in areas such as silicon photonics, VLSI chipset development for high-speed interconnects, balanced system architectures, and software. So the participation in this program is really providing HPE a laser-like focus and a collaboration environment through co-design with various labs to ensure that the work that we're doing and the technologies that we're developing are indeed what's needed to solve the mission-critical problems. So over the course of this 3-year program, many of these core technologies will find their way into HPC products and into HPE roadmaps. And this we see as a way to ensure the long-term success and the long-term utility of these developments that we are undertaking under this program. And that key to our approach is an open industry approach as well, where many of the technologies that we're developing are in concert with open industry standards as well. And we're doing so in tight collaboration and coordination with our industry partners. So we believe that HPE is uniquely positioned to develop these technologies and systems needed to achieve these highly capable exascale systems. We are also uniquely positioned to deliver these technologies and resulting products broadly broadly into the high-performance computing market and also broadly into the commercial and enterprise space as well. So we are very pleased to participate in this program, and we believe that the outcome and the effect in our ability to deliver systems more broadly to a market will be realized. So thank you.
We'll come back to that. How about Intel? Do we have Al Garrow on the line?
Hi, this is Al Garrow. Can you hear me, Mike?
I can, Al. Go ahead.
Okay. So first, Intel certainly appreciates this award and looks forward to continuing to try to aggressively approach exascale. So DOE's leadership, we feel, is critical to really accelerate high performance computing and address these challenges that we have for exascale. We know that power, which has been a challenge for a long time, is now a challenge really at all scales. Cost, which we sometimes set aside for some of these R&D programs, is really one of the biggest constraints that we need to address. And so we're also focused on not only building higher performance and more power efficient components, but those that can be done at a reasonable cost. And finally, the usability of these systems is really fundamental, right? We're not just building flops. We really want to build highly scalable machines that are really usable. So as I said, we want to approach exascale, but exascale from Intel's perspective is not only about high performance computing, it's also about artificial intelligence and data analytics. We think that these three really are now all part of the solution and need to be encompassed in any solution. So HPC, or high performance computing, is continuing to grow. It's really established itself at this point as one of the three pillars of scientific discovery, along with theory and experiment. That artificial intelligence is quickly growing, and probably the fastest growing segment of computing, whereas we find ways to efficiently use data to learn relationships and make accurate predictions. And this ability is being used in many places, commercial and in the scientific research environment. So this, as well as in the traditional environment, we're also using this capability to accelerate the traditional simulations as a new method of augmenting that. So we also feel that exascale computing, in totality, it will really enrich the lives of many people on the planet. It will enable us to build better, quieter wind farms, more efficient batteries, which has really become sort of a international race to develop the best, most power efficient battery, and as a result, is really a grand challenge problem that is really critical for the nation. Other areas, there's many areas, but just to mention another, healthcare, of course, is on everyone's mind. The ability to both analyze large databases to find patterns and develop personal treatment, as well as cancer research, are really target areas where exascale computing will really be targeted and make an enormous impact on all of our lives. So the partnership with DOE really allows industry to co-design systems with ingredients, and I think the co-design is really critical here. So it allows us to put world-class application developers and scientists together with Intel's best architects, and really creates an environment that we expect will result in the best possible solutions to address these very, very challenging but important challenges ahead. So as I said, usable machines are really the key thing here. We're trying to in the end, result in not just a machine with a high peak performance, but really one that can address real problems. The other challenge is that right now we do have lots of revolutionary new technologies, as well as new workloads that are emerging. And so this coupling and partnership with DOE on co-design is really critical, and the timing of this couldn't be better. Thanks, Mike.
Thank you, Al. And we'll now go to Bill Dally from NVIDIA.
Hi, this is Bill Dally at NVIDIA. Can you hear me?
We can hear you.
Yeah, so Good afternoon. I'm Bill Dally. I'm Chief Scientist and Senior Vice President of Research here at NVIDIA. And all of us at NVIDIA are very excited about the opportunity of working with DOE to advance high-performance computing and further improve the efficiencies of GPU accelerators. This work being supported under Path Forward is really critical for several reasons. First, it helps us identify novel approaches to improve the performance and efficiency of our GPUs that benefits a whole host of applications in high-performance computing and artificial intelligence. It also allows us to focus on improving the resilience of our GPUs, which allows them to be applied at greater scale than in the past and ultimately get us to exascale computing. Second, the collaboration with DOE scientists allows us to understand their problems better and make sure that the technology we develop is focused on solving those problems and is a good match for them. We've had great success working with the DOE on many previous contracts with co-design, and that's resulted in many innovative features in our GPUs that have made them much more effective at DOE applications. And finally, this federal research has helped us develop new technology that's incorporated into our Volta GPUs, technologies like NVLink, that will be used in the upcoming flagship Summit and Sierra supercomputers that we're building in collaboration with IBM. The Volta GPUs will deliver over 90% of the computing flops in those systems and will ensure American leadership in scientific research and national competitiveness. I think it's also important to understand that Summit and Sierra and all the machines we build with GPUs are not just flop machines and not intended to accelerate high-performance LINPACK. That's actually not important for competitiveness. What is important today for competitiveness is accelerating a combination of AI and simulation, combining the ability to do deep learning very effectively with traditional physical modeling. That's how future scientific computations are being done. And actually on this workload, the Summit and Sierra supercomputers as delivered will be exascale machines. They will have over an exaflop of floating point performance in the tensor cores that are used for the deep learning part of that computation. We have a long and rich history of doing research on high performance computing at NVIDIA. We've been doing it for over a decade, and Path Forward is our 6th contract with the Department of Energy for research on this topic. And it's all of these have helped to accelerate efficient throughput computing. This particular contract will focus on critical areas, including energy efficient GPU architectures and resilience. Our findings will almost certainly be incorporated into future generations of GPUs that are after the Volta generation. Previous research contracts, for example, under the Fast Forward and Design Forward programs, have led to major innovations that have been incorporated in our Maxwell, Pascal, and Volta GPUs, such as energy efficient circuits and the NVLink interconnect. So we're very excited to be working closely with the Department of Energy and with several national laboratories, including Argonne, Los Alamos, Lawrence Livermore, Lawrence Berkeley, Oak Ridge, and Sandia on this program, which we think is going to be very important for the scientific discovery and for the economic competitiveness of the nation. Thank you very much.
Thank you, Bill. One more time, we'll have a call here for IBM. Is there anyone on the line from IBM that would like to speak?
Hi, Mike. Can you hear me? This is Jim.
Yes, Jim, I can hear you.
So thank you again. So my name is James Sexton. I'm director for the Data Centric Systems Group in IBM. And we are very excited once again to work with DOE, and we would like to thank DOE very much for this opportunity. We believe that the Path Forward program that DOE is announcing today will help accelerate our capabilities to deliver cognitive, flexible, cost-effective, and energy-efficient exascale class systems, both for DOE mission, but also for more broadly for commercial activities for the nation. We see our solutions to be both on-premise solutions and cloud solutions. Our vision for exascale computing is driven by 3 basic considerations. First, we do believe that future computing is going to be very data-centric, and we are focused very much on building solutions that allow complex analytics, modeling, and simulation to execute on very large data sets. We see the major technical challenges to an exascale design to be power efficiency, reliability, scalability, programmability. And we feel very strongly that those challenges needed to be addressed in the context of a full systems design effort. And they must further be driven by requirements. And our DOE missions are providing some of the most challenging computational and analytics requirements anywhere in the world. So we are very pleased to be working with DOE. And then we do also believe that the work we do has to also be viable for commercial products. Building custom systems is too expensive and doesn't make sense to us to do that. We see the Path Forward program here as an excellent opportunity to advance state-of-the-art in all aspects of systems architecture. Our focus will enable significant enhancements in the architecture and will feed through to expected commercial offerings as we deliver exascale systems to DOE. And we do thank DOE for the opportunity again, and we are really looking forward to working with them on this really exciting challenge. So thank you, Michael.
Thank you, Jim. Very good. All right. At this point, we have several questions that I'll pass along now for Paul. This one comes from Rick Merritt at EE Times. And the question is, how would you characterize supercomputer leadership of the US versus China? Specifically, does the Exascale project now aim to deliver a single system in 2021 at 30 megawatts to catch up with China?
Thank you, Mike. Well, on the last part, our current plan is to have delivery of at least one, not necessarily one, system delivered in 2021. I would not characterize that as to catch up with China. We do know, of course, that China has indicated they plan to have at least one exascale system in 2020. But we, for example, do not know whether that system in China will be a peak exaflop system versus what we're planning to deliver through the project and associated facilities activities is what we call exascale capability, which is measured in actual applications performance as opposed to a peak speed. But I guess the concise answer to your question is, at least one system in 2021, and another one, if not in 2021, in 2022.
Okay, and let me add for everyone on the line that if you have any questions that you don't get to ask or think of some later, please just email them to me and I'll get them routed to the appropriate person and get a response to you as quickly as we can. So we have one from Pat Thibodeau, and Pat asks, what will the firms be required to deliver at the end of 3 years? So what is the time frame for a fully functioning exascale system? In question mark, the plan is to build 2. And how much money will you need to reach the final project goals?
Okay, that sounds like 3 questions to me, but that's fine.
It is.
So the firms will be required to deliver final reports on the outcomes of their research. But I think it's very important to note that, as I indicated, this is a co-design effort with other activities, and we will be having frequent, formally scheduled intermediate reviews every few months of the activities. The funding for each of the vendors is based on specific work packages. And so as each work package is delivered, which would be an investigation on a particular aspect of their research, as it's delivered, it will be evaluated. In between times, we will have progress reports, and applications developers, system software developers, software library developers, for example, will participate in those evaluations. So it isn't that we send the money, wait 3 years, and get an answer. And that's very important because through co-design, the firms involved will get insight into our needs and can adjust to the requirements as much as feasible. And at the same time, the applications developers and the software developers in the project will have early information about potential aspects of exascale systems and be thinking about those. Now, for the second question, the time frame for fully functioning exascale system, as I indicated in the answer to the first question, the Department of Energy plans to deliver at least 2 systems, at least 1 in 2021, possibly 2, and others in perhaps later. And by fully functioning, I would say if it's delivered in 2021, or one or both, historically it takes a few months for first-of-a-kind innovative systems to be fully functioning. So if by that you mean production, it would probably be 2022. If by fully functioning you mean that the whole system is put together and it can run applications, but it's not in full production mode, that could be as early as 2021 itself. Now, the money to reach the final project goals, well, of course, that depends partly on the results from this Path Forward funding. As you heard, several of the vendors' statements, bringing down the cost is part of the goal. And so the systems will be purchased not by the project, but by the facilities that normally house the leading computing resources at Department of Energy labs, such as Oak Ridge, Argonne, Livermore, Los Alamos, Berkeley. And it will be those facilities that will be purchasing the systems, and how much it will cost will, hopefully be reduced a bit by this Path Forward funding. So I can't provide a number because it's a moving target for the entire project, including the purchase of the systems.
Okay, let's see, we have another one here. Another one from Rick Merritt. Can you give total expected government and industry investments expected over the life of the program?
The life of the program being the Path Forward program, I presume. So the total investment is estimated at $430 million, which is the $258 million that DOE is contributing, and the rest of it is what the companies are contributing through what is a fairly common arrangement that DOE has for contracts of this type.
Do we have any other questions? Okay, nothing here. Go ahead.
This is Addison Snell with Intersect 360 Research. Can you hear me?
Yes, Addison.
Can anyone talk specifically to what work is being done on software to enable applications or modeling and simulation at scale? Co-design did come up a couple of times, but I'd like to get a sense of, is there work on programming models, or basically what work is being done for the software ecosystem?
This is Paul Messina, Addison. Are you referring to work done as part of the Path Forward Awards or as part of the Exascale Computing Project? The other parts of
I was thinking about the Path Forward Awards in particular.
So the majority of the work under Path Forward is not on the software, but I anticipate that some software will be developed that'll be needed to get a handle on the things like the programmability and the efficiency of actually using such systems. But the project itself, the Exascale Computing Project, is investing heavily in software technology. And as I mentioned, through co-design, certainly there will be a lot of interaction with the companies on that, on the software aspect in the context of Path Forward.
Thank you.
Now, we've had one question come in asking for if it's possible to get more specifics on the projects that each vendor is undertaking. I think that would best be handled off of this call and dealing directly with each vendor who can talk at that level about what they are specifically working on and what they're willing to share. Let's see, we have a question coming in from Inside HPC, which says, what is the status of the Aurora system that was supposed to come to Argonne?
At present, I believe that the Aurora system contract is being reviewed for potential changes that would result in a subsequent system in a different time frame from the original Aurora system. But since that's just early negotiations, I don't think we can be any more specific than that.
Okay, and we have, let's see, questions coming in here. Pat Thibodeau raises the question, the labs will order the systems, so is that apart or separate from this funding?
Yes. Yeah, our funding situation can be a little bit difficult to describe. So there's the Exascale Computing Project, of which Path Forward is definitely a part. Path Forward is a program within the Exascale Computing Project. However, funding for the acquisition and the siting of the systems will, as is usually the case, be within the budgets of the facilities that I mentioned earlier as examples. So those facilities normally buy systems every few years. They, through their budgets, do the site preparation, usually also have non-recurring engineering contracts, and then there's a build contract for the system. So the facilities will be doing that with the facilities budgets. Part of that you can think of as, in the context of Exascale, as part of the Exascale Computing Initiative, which is broader than the Exascale Computing Project. So the facilities buy the systems and house them, and that is separate from the Exascale Computing Project. The Path Forward program is a substantial part of the Exascale Computing Project, but as you may be aware, other parts are software technology, which involves software from system software all the way up through libraries, programming models, and so on, and in particular applications development, which has a very large part of the budget, as is appropriate to develop applications that address a lot of critical mission needs.
Here's one from Tiffany Trader at HPC Wire, who asks, are you planning a second Path Forward RFP for the 2021 systems?
At present, we are not, Tiffany.
All right. Well, we're right up about to the 2:45 time here. So, Paul, did you want to make any closing remarks?
Don't have anything too much to say other than I appreciate so many of the community that reports on these activities to be present and for the questions. And certainly looking very much forward to working with those 6 leading companies on getting us to Exascale in the best possible way. Thank you.